Hi, Mariana. Welcome. How are you doing?
Hi, Dario. Thank you so much for having me today. Very glad to be here.
I think, it was we were supposed to have this conversation here, like to do it in person, but unfortunately in these times it's a little bit complicated. So,
Yeah, I would also have preferred it personally, but I'm traveling home this week and I don't want to take unnecessarily risks. So
yes,
maybe let's thank technology for having this option as well, right?
yes. Actually, I don't complain about it because, as you said, like we also want to have some good holidays.
No,
So it's not only you, me, or whatever. So it's like good to have this opportunity before ending the year.
absolutely.
So thank you very much. So I first want to talk a little bit about your profile, if you are okay with that. So just so people know who you are and why we're having this conversation. And so first of all, I think one of the things we were talking before starting the conversation, officially recording the conversation, like how happy or how glad I am that you are also here as a entrepreneur, as a woman, as a Latin also. Like you are the whole deal. You're the big deal. Like you're killing it in my opinion, and that's really amazing in my opinion. I'm inspired, by the way. So really,
Most of the things are things for which I take credit. I mean, I definitely don't take credit for being a Latina. Also, do the Brazilians classify as Latinos? That's like
yes,
one of the questions that people will never get a good answer to.
yes. Like all South America, just put like Latino.
Oh, South American. I've heard Brazilians have like two different opinions on those. So I've heard people saying that Latinos must speak Spanish, and then Brazilians get very annoyed because we don't speak Spanish, and we get annoyed if people think that we speak Spanish.
Maybe you have heard it, but Italians are also sometimes considered.
Yeah, exactly. But if you consider the Italians and the Spanish, then we also fit in.
Yeah, and I'm not saying that that's your biggest accomplishment or so by any means. What I'm saying is just like it's amazing to see that on top of what you already achieved. And let me tell what is that about, so everybody knows. So you are originally from Brazil, Sao Paulo. You studied also computer science, your bachelor's degree. Also, your master's degree is also in computer science. Is that right? And you finally got your PhD, your doctorate back in September this year. Congratulations. In applied software engineering, is that correct?
Yes.
Okay, great. You also were the founder and project leader of WARR Hyperloop team back in 2017. In that period, you won the first place.
Wait, no, 1 second, small correction. I founded the team in 2015, but the competition was 2017. You have the competition date. It's beginning of 2017, so it's like mid 2015 to beginning 2017. So that's like the 1.5 years that come in place. But I actually started in 2015.
So you were preparing for that competition,
yes,
I guess.
Yes.
Okay. You will let us know or explain us a little bit more about a little bit later. And in this competition, you won the first place in the SpaceX competition for the fastest spot. Is that correct? Great. So you also have many awards. There were so many that I got just the top 2 or 3. Like you were included in the inspiring 50 women in the DACH region last year.
Yes.
So that's kind of cool. 2019 or this year?
2019, yeah, last year, last year.
Okay.
Yeah.
So that's actually pretty good. You're also a panelist. You're a speaker, a keynote speaker. Yes. You're author of several publications. You're also the co-ambassador of the Munich Geekities. So you will also let me know what that is about.
Yes.
Okay. And finally, you are also an entrepreneur and co-founder, project lead, and developer in, how do you pronounce it?
Moowe.
Moowe. Moowe. So that's what I said. Like on top of all of this, you're also here sharing some wisdom with us.
It's a very mixed background, that for sure.
No, but that's so totally interesting.
And I have lived in 5 different countries.
Okay, including China, Italy, Germany?
No, not Italy. So Brazil, Germany, China, Singapore. I count Singapore as a country. It is a country.
Yes.
And United States. I actually lived 2 years in the US.
Mm-hmm. Okay. So that's actually like a lot of things you have accomplished and done. And you are so young for that, like compared to other people, I think.
Thank you. That sounds good to hear.
Yeah. you know, like when you start comparing ages and what people normally do, sorry. Yeah, you're like,
it's interesting because I took way too long to finish my studies. I took forever to finish my studies. I just extended my studies hundreds of times. I extended it because I was working. I extended it because I went to China, as if that wasn't enough. I needed to go to Singapore after that. Then at some point, like I finally managed to complete a bachelor. And it's like, cool, now let's do the master quite quick, right? Nope. Started a Hyperloop in the process, extended it because of the Hyperloop, extended the master's because of the Hyperloop. So indeed, I always thought that I was too old for what I was because I just took forever to graduate. But then I think I caught up a bit with a PhD because like when I started my PhD, I knew from day one that my professor was retiring. So I had the huge advantage of having a deadline to the whole thing, which is something normal doctorate people don't have. And I think I used that a bit. It's probably the only reason why I ever finished, by the way. And now I think I caught up. But like up until the end of my master's, I had this huge problem with myself because I thought, oh my God, I'm so old. I'm still studying. Like, how can it be that I'm still studying? I finished my master's with 27. It's like, it's 27. I'm 27 and don't even have a master's degree. And I had a huge problem with it.
Yeah, no, but think about it. Like you are 30 right now, 29?
31.
31, okay, almost. So you're in this age range. But just think about it, like who in the world, in a percentage, has a PhD already at 30, 31?
Which percentage of the world has a PhD in the first place, right? Which
exactly.
Probably much more than the percentage of the world that needs a PhD. So we can go into this whole conversation if we even need people with PhD
exactly.
Or not.
Yeah, exactly. So I would say less than 1% in the world. So
probably some more people who need a PhD, but
yeah,
more people have it than people need it. Definitely that.
I totally agree with that. No, yeah, and no, it's totally, you know, yeah, true. But I mean, I think it talks a lot about what you have done so far. So, and I think it also talks a lot about your work ethic and your mindset. So you maybe will share us a bit about that a little and a bit later. But first of all, I would like to ask you, why did you start in computer science? Like, why in this STEM field? Like look, I'm also an engineer, industrial engineer. So a lot of people say that's not an engineer. So I take that aside.
No, it is.
Okay.
I'm not sure if computer science is an engineering. Is computer science and engineering? We could also have a conversation about that.
Okay.
I know people on both sides of that conversation. Why computer science? So honest answer, it was completely random. Okay. It was 1000% random. It was actually not my first choice. It was actually not my second choice. It was my third choice. And you only end up studying your third choice if random things happen in the way which they did. So I finished school in Brazil. And once I finished school in Brazil, you always like at the end of high school, you always had that phase, oh my God, what I'm going to do, which study. And I had zero idea what I wanted, right? Like zero. Mm-hmm. The one thing I knew is I liked math and I liked building stuff. Or playing around, and I had a blog, you know, like these things you do when you're 16. So I had coded in HTML, and today I don't think that's coding, but back then I had like open HTML, and I thought that was amazing, right? But my first option, which I actually enrolled for and actually studied for 1 year, so also one of the reasons why it took too long to graduate, I studied 1 year business administration. And the Technical University of Munich actually has this business administration course with a lot of engineering to it. So I always knew I wanted something with engineering because I liked the math and I liked like the applied approach of it. And they had this business administration engineering course, which I thought was, hey, cool, I get to do a bit of both. I enrolled that. I studied that for 1 year. I had just moved from Brazil to Germany.
So quick question. How did that happen? Like, did you just came with the idea, I want to go to Germany because why not? Or what happened?
So this is where we start talking about privilege, right? Definitely not everyone can do what I did. And the reason why I came to Germany is I went to a Swiss school. So I started having some German already in Brazil, and I went to a Swiss school in Brazil. And so going to a Swiss school in Brazil is definitely a lot of privilege. And I knew I wanted to study outside of Brazil. And then you start talking, okay, where can I afford? So US was out of the list because it's quite expensive. Then Swiss school, you obviously think about Switzerland, but as a foreigner, ETH is actually expensive, and I did not have the grades for ETH. And then when you do the price quality measurement as a high school student, the TUM actually goes quite up. I mean, it's a very good university, very cheap. So indeed, I decided more for TUM than for Germany.
Okay.
So yeah, TUM. And I had visited Munich already during my high school years, and I love the city to this day. I still love the city. Coolest city in the world, if you ask me. Maybe cool is the wrong word. We can talk about this later. But yeah, I had come over and I enrolled in business administration with engineering. Mm-hmm. And this was in German, and I had just landed from Brazil, and my German was horrible. So I knew enough German to even get admitted, because you need to pass the German exam to even get admitted. And since I had passed the German exam, I thought I knew German, okay? So I thought, like, I passed the exam, it will be okay, well handed. I arrive at classes, and they talk to me like legal German or business German, which has like these words, and I'm completely lost, like so lost. I failed all the subjects except the math subjects.
Yeah, because math is your language, right?
Math doesn't matter the language. Math is universal. Math, you don't need the language, right? And so yeah, I failed everything. I was so quite just from failing everything and from knowing how hard it was, I realized quite early on in the process that I didn't want it, and I wanted to change subjects. And then I was like in the situation, I actually like Munich and love the city and definitely like the life. I had friends here. I like everything except university, which is how it's like, okay, instead of going back to Brazil, let's change courses, right? And since I had failed everything, like you have no idea what everything means, I had failed everything. I applied for a new course as soon as registrations opened, because I knew like, I don't want to do this. I applied as the second that registrations open, I applied. And I actually applied to mechatronics because it's like, you know what? Now I'm going to follow the engineering dream. Now let's be the engineer, and now let's do this.
Let's go for the difficult stuff first.
Let's go for the engineering league, mechatronics. Let's do this. It's a bit of computer science, a bit of engineering. It's the awesome mix. Yeah, mechatronics. I got rejected.
Well, just maybe we can give a little bit more context for it, because coming outside from Germany, maybe you experienced that, and I also experienced that. But maybe in Germany it's already known for saying something like that, and it's actually like public. Here the education in Germany is public, most of it.
Yes.
So the best education is public, and it's cheap, by the way. Cheap is cheap. Like I think like you pay like, I don't know, 20 euros.
140 euros per semester.
Yeah, it's nothing. So yeah, you pay more in here in a month.
But TUM is an amazing university. I can be TUM fangirl here.
But cheap doesn't mean bad, so by the way. So.
Yes, cheap as in inexpensive.
Exactly.
Because it's publicly funded, basically.
Exactly. So and it's really hard to get into many programs because there's a lot of competition. So I also tried. Was no, like walk in the park, and they were like, oh, now I know why. Like it's really competitive with people here. So maybe for you that was also the case.
I know exactly why I got rejected, indeed. I got rejected because I said I went to the Swiss school, right? And at the Swiss school, I had done this international bachelor to diploma, which got recognized as equivalent to the Abitur. And in this diploma, we had only a few subjects, so not all of the subjects. So I had my math high level, like advanced math, because I loved math back then. I don't even remember what all the subjects I had, but very importantly, I did not have physics. Mm-hmm. Inside of this diploma, I did not have physics, not even in the basic module, and neither basic nor advanced physics. I only had it in the Brazilian diploma. Because my school didn't offer the course. They back then there wasn't an option to do physics in there. It's not that I didn't want it, it's just that it wasn't an option. And therefore, and I mean, it's completely fair from TUM side to require physics if you're going to study engineering, right? and physics was a requirement for mechatronics. So basically, I got rejected from mechatronics, and for that same reason, I went around and I talked to people and I discovered that. And for that same reason, I would get rejected in all the courses of the mechanical engineering faculty, because physics was a requirement for all the courses in the mechanical engineering faculty. So now I had the situation where I was like, okay, I hate the course that I'm studying. I can't study anything in the mechanical engineering faculty. I could go back to Brazil, but that's not really what I wanted because I actually liked my life here. And I guess the only lucky thing in this whole story is that I applied as soon as applications opened, which means that by the time that I got the answer and the rejections, I had 3 days before applications closed.
So what do I choose from here?
So I had 3 days to register to try to apply for a different course, for a different course, for something else. And that's where computer science came in. Computer science was outside of the mechanical engineering faculty. I had a friend at this point that already studied computer science, and he told me about it. And I mean, I did like computers, and I had coded in HTML. And that's when I applied to computer science. So like third choice. Okay. That's how I landed there. Did pass, did get in, thankfully. And I'll tell you one thing, it was one of the, I say that there are like 2 amazing decisions that I did in my life, probably 3, probably need to add a third one by now. The first one was moving to Germany. The second one was choosing computer science. It was completely random, but definitely worth it. It was the ultimate proof that it was the right decision when after 1 semester of computer science, I had more ECTS that I had passed than after 1 year of business administration.
No, that sounds good. You know, like sometimes we need some kind of luck, and it seems like you made your decision and everything just starting to fall into place. So
it took 1 year to get to the correct place, but you know what? Better late than never.
Yeah. So, you know, like good things happen when you don't quit. So that's one of the examples. Cool. But then like, okay, you got your studies already, maybe, okay, after a while, maybe 3 years. I don't know how long.
I took longer than that. I extended my studies forever. I literally forgot how long it took me to study, but I can open in my CV if you want to.
Yeah, no, I have it somewhere here. So if we want to have some data, yeah, but you know, like I think we started almost at the same time. Here's you said that you started in 2009. So
yes, I started my bachelor's in 2009.
Oh, I see.
No, wait, my science bachelor I started in 2010. So 2009 I started business administration. 2010 I started computer science.
I see. Yeah. So yeah. Okay. Now I see why it took that time. Well, okay, but in the meantime, like you were also developing your own goals. I mean, maybe what were your expectations about like studying that, and what was the next step for that?
I really liked it. I really liked it. And I still have like so I had never coded before. My first line of code was in Introduction to Computer Science, first week of university, and I wrote Hello World in Java, and like that awesome moment where you write your first Hello World program. And even if 16-year-old me did think that she had done something that was HTML is not a programming language, so we're not considering it, okay? Even if 16-year-old me would disagree. So yeah, in university, you start with Java and programming, and then you very fastly realize the whole potential and everything that is possible in this whole new huge world. And it's very easy to fall in love with all the possibilities in there, right? Like when you're learning how to code, you really have this sense that everything is possible. The only blocker between what is possible and what is happening is your ability to make it work. And
is it possible though? In your opinion? In your opinion?
If everything is possible.
Yeah.
Most things, yes. Everything is probably an over-exaggerating, but most things probably yes. Most things, like, there's also a point, how are you defining possible, right? Is it possible to reach perfection in everything? Probably not. Is it possible to get something working for everything and having like a prototype? Usually, even if you have to make a lot of compromises in functionality or in cost or in time or in whatever, usually can get something working. You don't need to be perfect always.
No, but yeah, but you know, like I ask you because I think first of all, you need to understand programming in the first place, whatever the language is, to understand the possibilities, I guess, because
yes.
I think there is a big barrier, at least from my own perspective, is I think I told you the last time that we met each other, there is a barrier at least for myself or people like myself that, to code, because it's like, I understand something, but when the I don't know if it's a specific language or so, but when everything starts getting more complicated, like how do I translate everything that I'm thinking into that? And first you need to.
Quick question, do you code?
I tried to do some basic stuff, but then I was like, okay, I think this is not for me. I need to play to my strengths.
Let me answer the question for you. Try to do some basic stuff is yes, you do. Okay. So then that's where the experience comes in. So basically you code, but you lack the experience of sitting down and doing something big, right? Okay. Which is valid. That's not what you work with. So it's completely valid.
I mean, if making a line is coding, then I did. But no, I'm not saying I just did a line, but
I mean, I do think that writing a function, and I do think, I mean, obviously there is the base, you can obviously get much more complex than that, right? But I do think that people should, I mean, I think if everyone in the world coded at that level, the world would be a better place. That I do think. I don't need everyone to be the huge specialist or anything like that, but just like that, the basic level, I think. Because from then on, it's basically logic and complexity. So you need to organize and getting some ideas of what are the best ways to organize. And there are like standard practices of design patterns and architectures of how to do this, which is what you spend the rest of the computer science for course learning. But that's basically how to organize things and the mathematical complexity of it. But that's just adding complexity and organization layers to it.
Okay, I have a quick question for you regarding this topic. So, like, so we have computer science. I think not everybody is capable to organize their thoughts to do that. Do you think so?
I think that is definitely the reason why many people have problems coding, and that is probably the reason for so many of the bugs in so many of the systems worldwide. Okay. Problem organizing thing, that's definitely a hard thing to do. That is definitely an important skill when programming large systems, at least large systems. Yeah, definitely.
Okay, so is, in your opinion, everybody can do it?
I absolutely 100% think that everyone who wants to code can learn how to code.
Okay, is there a path for anybody that is watching this? Because right now we're starting in a basic mode, you know, like first this is for dummies like myself, and then we start going into more complicated stuff. So
the path is first choose a programming language. If you are completely unaware and lost in which one to choose, a decent starting one is something like Python because it's very easy. You can always do the JavaScript, but JavaScript, I'm not a JavaScript fan. I have a problem with JavaScript. So no, I love Python. Python is amazing. If you want to do big complex systems and you may want to do something Java, then Java definitely has its advantages. If you just want to get something working fast and easy, then Python is usually easier.
Okay.
So first step is decide your language. Second step is Google programming language tutorial. And the second you do that, we'll probably get like millions of search results because, and that's where it actually starts to get hard. Because that's a step where it starts to get a bit overwhelming, right?
Yes.
And unfortunately, this is only going out later this week because actually tomorrow at exactly this time, the Munich Geekettes are hosting an event called Embracing Coding, where we're going to talk exactly about this topic. So I don't want to spoil too much of our event tomorrow.
Don't worry, by the time this is going to be posted,
by the time this is posted, the event will be over. Yeah, true. So for anyone watching this later, follow the Munich Geekettes on Facebook, Instagram. We're so awesome.
Okay, so you're going to post what happened in this.
We can talk about it. Not sure. That's not currently planned, but that would be interesting. Maybe
you can do a Facebook Live, you know, with a cell phone.
Wait, can talk about this. Can discuss.
Okay.
So yeah. Second step is Googling and finding yourself a tutorial. then depending on the language, you may need to install some software to even be able to get the programming language to run, which is the step that most people give up on.
Mm-hmm.
So that's for me is like the one advantage of JavaScript is that everyone in the world, every computer in the world has a program that runs JavaScript because every browser does, and everyone has a browser in their computer installed, right? That's a step where people usually get lost. So for Python, you do need to install a package, for example, to run Python code if it doesn't come. So some operating systems, it comes automatically, but not all. And that is definitely a step where many people get lost because it starts getting scary and you start installing things in your machine that you don't completely understand. So the one thing I can only recommend is don't give up at that step. That step is, and if you give up at that step, then I'd rather you learn JavaScript than don't learn anything. Then if you're scared of that step, then go for JavaScript. Even if I don't like JavaScript, I will allow it to come up in that one case.
Okay.
And then it's basically sitting and practicing and going and like sitting, practicing. Coding is really something that you learn by doing. It's much more about the practice than about the theory, in my opinion. There are probably people who would disagree with this, but I think the easiest way to learn is by hands-on, sitting down and doing it.
So one person that doesn't have the, let's say, the opportunity to go and have a degree, let's say a bachelor's degree or a master's degree or a PhD degree into computer science or informatics, you can learn it by Googling it, YouTube, and practicing and get good at it if you want.
Yes, so much yes. I mean, honestly, just by Google, you can learn so much. And there are actually some very cool programs. So just last week or 2 weeks ago, I don't have, in 2020, time is an abstract concept.
Yes.
Time does not exist in 2020. I do not know if this is 1 or 2 weeks ago, but recently I just had a talk with the people from CodeJam, for example. Codam. And they are a coding school in Amsterdam. And I talked to the people from the Amsterdam chapter, but they actually have things all over the world. And basically they will teach you everything you need to get a job. It's not just to code, it's to get a job in programming and in software engineering without you ever attending university, and everyone can do it. I mean, yeah, you can go online and search for the application.
I think it's just like Ready School. I think it's similar.
It's a bit so. Codam has a bit of their own methodology, and they were talking to me about. They basically gamified studying, which I thought was like amazing. So you have levels, and you need to pass on to the levels, and I thought it was a really cool curriculum / concept. So like gamifying.
It's more like a challenge.
Yes, it is more like a challenge, and coding is a challenge. It makes complete sense. But yeah, in Munich you also have Ready schools. There are so many schools worldwide. I mean, it's basically a question of how much time you want to put into it, right? Obviously, the more time you put into it, the better you get.
Yeah, I think right now what I am trying to get from at least this information that you're giving us is how can you just land everything that is out there and just put it into your simple steps? Because I think that's one of the more complicated things that anybody can do. And asking you that having all this information and all this experience is just like, dude, just go there, follow the tutorial, the YouTube tutorial, stick to it, try it.
I should have gotten it. If I knew I was going to get that question, I would have prepared my little plate. My boyfriend gave to me as a present a plate, which is like one step at a time. It's like this stick figure going up a stairs, and it just says, and it's a bubble called one step at a time. Yeah. And that's probably the present that I got that most defines myself, because that's really my life motto, you know, one step at a time. One, not 20, not 0, one. Don't do 20 things at the same time. Do one step at a time. So first step, decide the language, install the things. After you install the compiler or whatever you need to install, next step, print hello world. Very simple step. Yeah. Print hello world. If you want to go after that, you can transform hello world into a function. That instead of printing hello world can print whichever argument you get as a parameter of a function. And those are small steps, but simply the fact that you're making progress already motivates you a bit. Already motivates you to keep forward. I think one of the places where people get lost is like, my code doesn't work. I have no idea why. I've been debugging this for 25 hours and I'm making no progress. And then that's where it starts to get frustrating and people get lost. But I'm a huge believer that, and you know what? If then you ask for help, and those are the steps that will happen, that has happened to everyone. If you ask for help, it's usually such a small thing that you're just so tired and you overlooked, and the second someone helps you out with, it's like, that was so obvious.
Yeah.
That
like you just need some fresh eyes on your work, maybe.
Yeah. That moment is the moment people actually do learn how to code, and everyone has had that moment. Everyone.
Yeah, and the other reason why I'm asking you this is because one of the things that we talked last time that we met each other, and before starting this conversation, is that also the importance of, let's say, bringing this information to, in this case, specifically to women, like just so they can see that it's also possible and doable, and it's so they don't need to be afraid of going into sciences and computers and maybe engineering, as long as they have interest, right? Because if they are not interested, then yeah, it's not.
To any woman, girl, whatever age watching this, anytime in the future, if you want to learn how to code and want to do something, to go in that direction, and you're stuck in whichever point it is, and you're about to give up, LinkedIn me. If you LinkedIn me, you can find me. Write me in LinkedIn. Write me. I'd much rather you write me than you give up. Okay, at any point in the future. Me or anyone else on the internet. There are hundreds of people in the internet that will help you out with these things. Many of them 1,000 times better than I am. I'm not the best coder in the world. I really ain't. I'm not. I got rejected at the Google software engineering interview. I also got rejected at other software engineering interviews other than Google. But because I really am not the best software engineer, if you want someone to write the most perfect code on the planet, you can always find someone that will be able to do that better than I can. But so often it's not about writing the most perfect code on the planet. It's about getting it to work. It's about making the first step. First get it to work, and then refactor, and then make it pretty and efficient and optimized and all, and organized and structured, and test it, please test, and all of that. But first, get it to work.
And then improve on it.
And then improve on it. And take however many iterations improving on it as time allows you to.
Functional first, then aesthetics.
The people from test-driven development would probably kill me at this point, because they first write the test-driven development, TDD, is this programming practice where you first write the test and then make it work. And the idea behind it is, if you write the test, then you know what you need to pay attention to, and then you will get it to work. But even in the TDD field, where you first write the test, then make it work, then refactor it. You still have the fact, refactor it and make it pretty before writing new tests and covering new cases. Even then, it's first test, then getting it to work, and then making it pretty. Don't try to make it perfect on the first turn. Please don't. First, get it to work.
Okay, I'm gonna take a step backwards. And what is possible for someone that wants to code? Because at least from my conception is, okay, websites, apps, technology, but as simple as possible, right? So it's like, oh, I would like to make an app, and it's like, okay, but what kind of an app? And I don't know exactly what kind of functionality or whatever I want to do. So, and not knowing how to code, then that's also a problem. And it's like, okay, I don't know. So then I give up.
Gets us back to the discussion, which is the first language to go through, and what is possible definitely depends on which language you're going with. So if you want to do an app, then your go-to languages are going to be either Swift for iOS, or Kotlin / for Android. Android supports both. But I mean, Swift, I don't know Kotlin, but I do know Swift. Swift is a very cool language, and it's even actually, if you're rich enough to have Apple devices everywhere, that's probably the biggest disadvantage of Swift. It requires Apple devices. So if you have that, Swift is also a very interesting programming language, because you can quite fastly do in Apple Playgrounds just a very simple thing, and from there on do it into an application, and you can even copy paste the code from the playground to the app, and it will still work. So if you are rich enough to have Apple devices, you can always do Swift. If not, I don't know enough Kotlin to say if I would recommend it or not, but I will talk about other things other than apps, or especially other than native apps. It gets us back to my JavaScript hate. If you want to do a website, JavaScript for sure, and even and if you want to do a website, there are hundreds of, like thousands, probably thousands of online helpers and online builders and website builders out there. If you want to do a website, just get to any WordPress thing or whatever, but that's still not coding. Coding, it's considered coding the second you start using some logic to it. So if you're just doing HTML and CSS, that's not coding. If you're doing JavaScript, then that is coding. So if you want to do something with a easy user interface and just an easy website, you can go for JavaScript. The reason why I personally hate it is because it's a language that is very hard to be your first language because it has very bad error messages. So you always get to the point where it's not working and then you need to read the error message and try to debug it. Doing that in JavaScript is really hard because the error messages that you get back are just like the most useless things on the planet, like honestly. And the second reason I don't like JavaScript is that they skipped a few of the very important programming concepts that just completely doesn't apply there. So that's the problem with that. But it is a very easy, you can get something very simple quite easy. It gets a bit harder when you scale. If you are less tight on the user interface point, if you just want to train the logic for it, train the logic of programming and get amazing things to work, but you're okay with maybe just a graph output or a console or a log output, then definitely Python. Python is beautiful because the syntax is super simple. You print quotation marks, hello world, quotation marks, close parenthesis, that's it. Python has a beautiful, simple syntax. Yeah, really awesome, amazing. And it is very, very, very powerful in that it has hundreds of amazing libraries, like very complicated mathematical optimization things. In Python, it's a two-liner because it's import whatever, import numpy np dot complicated function will do anything you want. In Python, very complex things are a two-liner. And that makes it much easier to just like see the whole things evolve, right? And then it's really easy to do very complex things. That's the reason I like Python. It's a perfect language to just prototype anything super fast. And disadvantage though is the user interface. There are ways to do user interface on it, but it gets a bit harder. But if you can live with just a log and some graphs, amazing graphs frameworks in Python, then definitely Python.
Do you have an example, by the way, that you applied this? So just to do it more tangible.
An example where I applied this?
Yes.
Well, example where I applied Python definitely many times. Like, oh yes. So I was working on this project where we had we had home addresses for a few thousand people, I think. Okay. And I converted those home addresses to lat long so that I just had the geo coordinates of everyone. Okay. And basically what I needed to do was create a bus route that connects all these people as easy as possible, okay? To basically pick up all of these different people, a bus route that will do that. So and here we go one step at a time, right? For me, the first step is, okay, we need a bus route. What are the bus stops, okay? And if you go a bit into the mathematical side, one way to, and if you graph all of these different points, basically what you want to do is group people into a single stop, right? And the second, and the mathematical theory side, the second you start thinking about the group, you're talking about clusters, okay? Please note that at this point I had no knowledge about clustering algorithms whatsoever. I just knew that I wanted to group people together into a bus stop because I've considered that finding the bus stop would be the first step in doing a bus route, okay?
Yeah.
Short Google about how to cluster people close together gave me the answer that K means clustering algorithm. Quite complex clustering algorithm. that does exactly this. And it's called k-means because it will output k points in the middle, in the mean of the group, basically. That's how the algorithm works. Very complex algorithm that does that, that calculates these points, and you need to give the number of the k, the number of groups as an input to the algorithm. Very complex algorithm that, I mean, not very complex, but relatively complex algorithm that does that. You can definitely understand it if you want to, and look into the algorithm itself. I didn't need to look into the algorithm itself. Python two-liner. It's a two-liner in Python. I don't remember if it was NumPy or Pandas. I think it was NumPy. I'm quite sure it was NumPy. Has the algorithm implemented to you. You just, and bam, there you have the center of the specific groups, and those are your bus stops.
Yeah, and then you are done with it.
And then you graph it. Then I graph. I mean, want to see it, right? So I love maps. I love maps. I think maps are one of the coolest data types that exists. Geographic information systems tells you so much about society. And then I mapped it as like, oh yeah, that's a point that would make sense. Sometimes it would be like, I think I had one case where it was in the middle of the river because that was the middle of the group. So I mean, adjusted it to the road next to it, and you have then some manual adjustment process in it. Connect each of them to the ones that's close to it, and voila, you have a bus route.
Okay.
Took me an afternoon, a bit more than an afternoon to.
So
like
the application
so.
would be to optimize the timing and how to say that. The distance they are using and reducing fuel.
I mean, and then it brings us to the next point, right? So if you want to optimize the distance traveled, if you want to optimize the waiting time, how much people need to walk from their house to the bus station, if you want to optimize all of those things, you definitely can, and then it will definitely take you longer than the 6 hours that it took me, right? But the first step is getting something to work.
Okay.
The first step is get the bus stops. I'm quite sure I connected them even manually on the first. So it's like, oh, this one is next to this one, so let's go this. And I'm quite sure I even connected them manually because the first step is getting it to work. After that, you can think about, oh yeah, here's the river, so you need to put next to it. If you do this, then the distance will be a bit better. And you can even add like complicated optimization algorithms behind it, but that's not the first step. That's step number 2 or 3.
Okay. But in this case, for the application, would that be for, let's say, for planning purposes, like to planning the expansion of a city or the It
wasn't for planning the expansion of a city. It wasn't for planning the expansion of a city. No, it was for planning a bus route. It was actually for planning a bus route.
Okay. So
planning a bus route.
Because let's say the bus company, maybe they don't know what you know. So you can gather some information with a GPS, and then just put it into your program, and it's like, oh no, you should go here, 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 because this will be better for the
people, because then they walk. So basically, through the k-means algorithm, people were walking less to the bus stop. That's exactly what the algorithm optimizes for.
That's
so
the outcome.
It basically calculates the middle of it basically finds groups and calculates the middle of the group so that it's the shortest distance to each person in the group.
I remember I was doing something like this back at the university. I don't remember how was the name called, but I didn't. So in industrial engineering, what we used to do in some of the classes was to optimize things. So that's like the industrial engineer does, right? So you need to optimize a process. And I remember we were doing a project about queues. It was always about the problem about the queues, like queues in the supermarket, queues at the bank, queues in a line, production line. And it's like, okay, where is the bottleneck, and how do we actually just redistribute everything so this will not become the bottleneck, but once you change it, the next part of the process will be the bottleneck. So you need to first design it. I don't remember the name of the program, but we needed to design it, test it, and run it so many times, and to see if there were crashes. And this was only to see that. I don't remember. I think
you just mentioned a very important part about it. So obviously, it's much cooler if things are optimized and if things are perfect, right?
Yes.
In mathematical words, perfect is optimized, right? Completely 100% optimized. But you can only optimize. It only makes sense to optimize if you know what the bottleneck is. And I think that's like the key word of what you just said is, and you can only know if what the bottleneck is if you already have something running and working in the first place.
Yes.
So it doesn't make sense to start by the optimization. I would always start by the implementation, then run it, and maybe it's good enough. Maybe I don't even need the optimization, but maybe it is taking too long at some step. It does happen. So Moowe, for example, we have the problem that our server is loading it takes forever to load, right? So we did identify that as a bottleneck, and we're now working on it. But you first need to get something to work, then you can identify the bottleneck, and then you can optimize it. Because if you don't do it like that, if you start by the optimization, you run the risk of spending so much time, and you can really like spend infinite amount of times in these things, optimizing something that is completely useless, that will bring nothing.
But you know, that's the beautiful part about the engineering, because we come together somehow. It's cool.
It is the beautiful part about engineering.
Okay, cool. I like it. So, and just to do a little bit more of transitioning about either your, like a mixture between your experience and your studies, because right now we went into a little bit of that, but continuing with your experience. So you were in your bachelor's degree, you said you postponed it for whatever reason, you went also to China, and then you came back. And and all of this, then you got into your master's degree. So why keep studying computer science? Did you like it that much?
Because at this point I knew I loved it. Okay. At this point I could not imagine doing anything else.
Okay, but back then, and right now I would say so.
Yes, no, back then. So by the time I finished my bachelor's, I really knew like this is what I want to do. But
one of the things I read about your description was like you like research.
Yeah, I do. I like applied research.
Okay, so can you tell us a little bit more about that? Like both about the research part and the applied research.
The research part is a bit related to what we were just talking about, right? The research part is about like getting data to know what to optimize. So if we're going back, like research is all about optimization and finding like the perfect solutions, right? But it has a lot to do with knowing what to optimize and playing around with all that, because usually when you have a problem to solve, you can usually have like 20,000 ways of doing it. And research is a lot about finding the best way to do it. And applied research is a lot about using data to do that. I did my PhD at the chair of applied software engineering. And I always say that my boss had the best chair name on the planet, because honestly, what in the world right now is not applied software engineering. Basically, everything in the world is applied software engineering, if you ask me, because everything has some software running behind it, right? These days, even simple radio has some software running behind it. This podcast, right? Podcast should be like this reinvention of the radio. And right now we are filming this, we are doing this on Zoom, which has a lot of software behind it. So yeah, everything is applied software engineering, if you ask me. And the reason I like applied is basically using the data to solve real world questions. So many of the people who work on research can get very lost in very, very, very theoretical questions, which are definitely very interesting to think about. But I want to work on something that I know will have a practical result and will somehow affect people, and I can actually see the results, right? Which is why I really like the applied part of it.
I think, yeah, I mean, that's one of the reasons why there are teams, right? Because there are some people that they are like total geeks of research. Like, no, just leave me here. This is
there are the people who love optimizing to the last millimeter. Yeah, no, and usually they have beautiful mathematical models behind it that are just like so beautiful, like sexy beautiful. I like using them, not developing them. I love using them. I love like my k-means algorithm. I thought that was awesome that I could just like use. There's a perfect mathematical solution for my problem and just use it, right? 2 lines of Python, importing it and using it. Obviously, if you're coming up with that algorithm, then it requires a much more optimization and much deeper level of research.
Yeah, and you know, like that's a good reminder that you were saying, because the fact that we use technology is like we need to remember, like, I mean, we normal people that we are not into computer sciences and programming and all this stuff, that whatever you have in your hands, that now we are like cyborgs, right? Like you are all the time next to your cell phone or the computer. So there was someone, at least someone doing that could work for you. So now you can just and spend your time just watching those stupid memes. So
you have any idea how much thought is put into which meme to display to you next?
Yeah, exactly.
There are very complex mathematical models behind which meme to show you next.
Yeah, I think so. Did you watch the documentary in Netflix, this social dilemma?
Yes, I did. Yes, I did.
Yeah. So when I started watching the AI,
I can highly recommend it. It's a very good one.
The AI behind it. I mean, of course, it's for a wider audience. Maybe you could understand. Maybe you already understand more about it. But when I started thinking that there was an AI bot or whatever that is, just looking at your patterns and just showing you whatever you want, so you stay longer there, it's like, oh shit! Like, I don't want to be manipulated, but you were, and you are.
But you are, and you absolutely are. You absolutely are, and that's the whole bubble that we live in, right? You live inside of the bubble that amazing AIs in the world tell you what to look next to, and then you always are looking into that, and then you stay in your bubble.
How do you find that? Like, what are your thoughts about that?
I can highly recommend the documentary to everyone. First thought about that is definitely scary. It definitely is responsible for a few of the problems that we are seeing in the world right now. It is definitely responsible for this huge polarization that we're seeing in the world right now. I remember like the last Brazilian election, right? And even the two last American elections, and Brexit, and the last Brazilian election, and so many of these things. It's just like this huge, it's one group against the other group, and there's zero middle ground. Yeah. And I think it's just disgusting the way that these things have evolved, because like if you're in this one group, you're only getting notifications and news and articles and comments about this one group, so you will reinforce all of the opinions in this one group, and you just stay there, and you will never move 1 millimeter in the other direction to get a different opinion on it.
Yeah, I think that at least for that, I was wondering what is happening, because like I heard other podcasters saying, I never saw the world so divided like nowadays. And I was like, why? You know, like, because before it was okay. Yeah, there were some times that it was really divided, right? The Cold War or so. But at least not everybody had an opinion or had access to that information. But at the end, like, what is happening? And
the access to information changed it a lot.
Yes, and I was questioning myself, like, why? Because I don't like either, you know, like if I go here, it's like
yes.
going to, yes. If I go here, then I will be either considered as this or that, or involved in this kind of thinking. And I think there is no good outcome if you just stand in one side of the equation. You need both, and you need to see the whole picture. That's my own approach. But most of the people is like, no, this is my standpoint, and I'm going to defend it, and fuck the rest, or something like that.
People are not open. So many people are not, I don't want to generalize because it's usually a bad idea to generalize, but I think so often people nowadays are not open to listening to the other side anymore. So, yeah, I think so often people are not open to listening to the other side anymore. And I do think that's a very big problem. Yeah, which is even a pity, right? Because you have the internet, like information has never been as reachable and accessible in the history of humanity as it is today. Like today, if I wanted, I know zero about medicine, chemistry, biology. I know zero about that stuff, okay? And usually I hate it. But today, if I wanted to learn how to perform a complicated surgery, I can find it online. I can find research papers and like top level research and status online. I mean, I don't want to because I hate the subject, but if I wanted to, I could. And the same goes for most fields in the world.
You know, one of the things that I think...
A lot of people use that.
I think one of the key things for that kind of, let's say, of behaviors like what you're talking about, like it should be like that, at least it would be like that, it would be good, is that you need to understand, like you, me, and everybody else, first of all, need to understand how to look for information, because
Yes.
because I think that's even more important. Because when I was talking to some friends of mine not long ago in the chat in WhatsApp and stuff, and I asked them, what do you think was the best thing from the university? Because I was so like, no, that didn't help me at anything, I didn't like it, blah blah blah. I was in this kind of,
Really, you didn't like university?
no, I liked it, but now in my present life, it's like, oh, it didn't work as I thought it would, you know, like like the picture was different, and it's like, oh, I needed more skills, more knowledge, more of everything to just keep with my current kind of life. So it's like, oh, that was not even enough. and you know, like, yeah, that's another story. But I was asking my friends, and one of them, he said something, I was like, and I cannot remember, I cannot forget it. And he said something like, they teach us how to think and how to research for data. So,
Yes.
like, so the way how you approach a problem and how
Yes.
you solve it and how do you find the right information to solve it, that's what is important. And I was like, bam, thank you. My whole like I shifted my whole.
And I think that is so much connected to like the core of computer science, because computer science at its absolute core is just logic. And logic seems so simple, right? And I remember in the university there was this course, the name of the course was called Logic, and it was logic for 8 ECTS, which means it was like a huge workload. And I was always so scared. Imagine taking logic for 8 ECTS. Logic, the beauty of logic is that it sounds so simple, but in reality it is not.
Yeah.
Logic can be very, very, very complicated. And the beauty of logic is that you can usually take the one step at a time approach to it to get to the complicated part. And you can usually start at the very simple, which is why I say first get something to work. And just being able to organize the hard part, going back to what we're talking about programming, right? The hard part about programming is not the computer part, it's the logic part. It's being able to, it's learning how to structure your thoughts into this one step at a time approach, breaking it down into the simplest steps in order to get those steps as simple as possible, and then getting them to work. That's the hard part about programming. It's simplifying the logic of what you need to do to its very, very core.
But I think that's in general the hard part of life, because
yes, which is why computer science so much explains life. See, agreed.
Yeah, because for example, I think we talked about that last time, but the fact that there are people telling you or explaining you things as simple as possible and that you understand them, is like, that thing is difficult. Like, just to pass information from one brain to another in a simple way, that means that the person that can explain you in the simple way already understands a lot, even how you think. So you could understand it, like, and you know, like, and chew it in small pieces.
And that is really just the beauty of the internet. Yesterday, I think it was yesterday, again, time is up, shit. These days, I was on YouTube and I started Googling or started watching some videos from Brian Greene explaining string theory.
Oh, like, yeah, I love that guy, yeah.
Like, string theory is a very complex topic, and I was just amazed about how the guy could make such a complex topic like, oh yeah, I'm actually understanding this. Yeah, it actually makes sense. And it's like, and yeah, then hours of YouTube and Theo. And
they make you love the topic. And that,
yes.
Yeah.
And that's access to information. Imagine 30 years ago, just a random person wanting to learn what string theory is, right? It's a very complex topic. And today it's possible, the basics of it, at least, with a few hours of YouTube.
Yeah. Yeah, I mean, of course, there are degrees, right?
So yes, obviously there are degrees. Obviously there are degrees. Obviously, yes. And obviously, if you want to go to the core of it, you can spend your entire life studying it. And the same thing applies to coding. Exactly. So obviously there are degrees to it, right? And if you want to be the biggest expert and implement the most optimized mathematical models, you do need the years of studying, the master's, maybe even the PhD, maybe the PhD.
Can someone
If
do
you
it without?
just want the basic
studying
level to
first?
get something to work, you can do that with a few hours of internet.
If someone has, let's say, if someone has the interest to do it and don't have the access, let's say someone in developing country, whatever, for example, cheers, and they don't have the access, but they have internet, so they can access to either.
If you have the internet, you have access.
Yeah, so, but just to the internet, not to the master's degree or to bachelor's degree in the whatever, in in Harvard or in Stanford or.
If you have internet, you have all the access you need.
Okay, and with that,
you also need time.
Yes, of course. Yeah, but yeah, you need to invest.
Those are the two resources that you need: time and the internet. That's it.
And interest. You need to also interested.
Correlates with time. If you don't have interest, then you don't have time.
Okay. Yeah, but with having that in account, can you get to a degree where, or to a certain point that you can actually be an expert on just by learning by yourself?
Yes, absolutely, yes.
I'm the same opinion, but I am asking you from this
1,000%
perspective.
1,000% yes, and I know people who have done it.
Mm-hmm. That's cool.
No, I know people. I was talking about our Geekets event tomorrow, right? One of the speakers tomorrow is a friend of mine, Argentinian that I met in Singapore. Mm-hmm. Amazing person. Comes from a biomedical engineering background, right? So not computer science at all. She does the whole biology part and the biomedical engineering part that I do not. Half of the time I don't understand her work. And the reason we got her as a speaker tomorrow is she's an amazing woman. She's also someone who we should really talk to in this podcast, must I say.
What is her name?
Mariana. You should really invite her. And she had the interest, and I remember so at some point she decided she wanted to learn how to code or whatever, and like the girl is just a phenomenon. Basically, she went from I want to learn how to code and have a background in biomedical engineering to she literally completed the Coursera machine learning. She completed the machine learning course and the deep learning one faster than I did because she had the time and interest to do it. Not because she's smarter. I mean, she is smarter than me, but that's a whole different topic. But simply, she invested more time than I did into the course. And honestly, in Coursera, Udemy, and whatever, you can learn anything. Coursera, Udemy, University of the People, you can learn anything. Yeah. And I when Tiana told me, oh yeah, I finished I basically got stuck at the machine learning course, and I never really finished it because I found something else to do and I lost my interest, right? So I never finished it. Yes. And Betiana comes to me and said, oh yeah, I finished the machine learning one and I'm almost finishing the deep learning one. I was like, what?
No, totally agree. Totally agree.
And I thought you couldn't code. And I thought I was the one with the computer science background. And Betiana just like, bam.
I totally agree. I mean, recently I discovered that there's so many things I want to know and so many things I want to learn, but I don't have the time. And it's like, shit, now I need to start like, defining what I want, because before that I was just learning from everything. Oh, this is good, this is nice, this is interesting. But now with less and less and less time, because now with the family, with work, with whatever, then it's like then you need to there is no time, and there are so many things to learn. And this is like for me it's annoying that I cannot learn.
The priority and focus is really, really hard. Like knowing what the priority is and this is the thing that I want to focus on and do first, that's actually really hard.
I'm waiting for the Neuralink so I can put everything into, like in the Matrix. It's just like, I just want to know everything about this. Done. Next. Would you do it, by the way?
If it's safe and FDA approved, yes.
Okay, yeah, I would do too.
If it's safe and has gone through all the levels of approvals and regulations that people require them to go through, then yes.
That would be so amazing. I heard one analysis about technology and people in general and society. Maybe you agree, or maybe you don't, or maybe there are parts of it that yes or no. The thing, or the comment about it was that technology and society, like technology is advancing so fast that people cannot keep with that kind of development. And there are so many people that will not keep with that because the technology goes, the rate of evolution is, I don't know how many times faster every time, that there are some people like, let's say, they don't even have access to technology or whatever, they will be just left behind, because it's like there is no way we can give you a job in technology because you're just too far. And that's regarding economics and of course opportunities and everything. So, and I was like, oh my god. So and they were talking also about the how much people are earning when, if you are in this part of the equation, like into the technology part, versus being a clerk or being a cleaning person. Or it's just like, oh, it's unfair. No, it's not unfair. It's just offer and demand. And the high paying jobs are here because everything, like society and humanity, is driven by technology right now. And all the other jobs are kind of like left behind, and they will be even less and less and less needed because of technology and robots and all this stuff. So that was like the general analysis. And I was like, where do I want to be? You know, do I want to be into the technology evolution part, or do I want to be in the, let's say, in services or whatever?
So I don't agree that technology is the only useful job of the next few centuries. I think there are enough very important jobs that will still be very important. We are in a year of a huge pandemic no one understood, and I think it will take a while before technology replaces doctors. It will definitely be very soon, and to a very high extent already is happening, that technology is helping doctors, and that already happens today with Tiana working at BrainLab. So technology helping doctors, that definitely yes, but for them to replace it, it will take a while. But we don't even need to talk about doctors, right? Doctors are also a very high paying job.
Yeah.
Let's talk about teachers. Going back to the education, I always say that if the world was a fair place, teachers would get paid the same things as doctor does. If the world was a fair place, that would really be true.
But do you think you need, like, that's the kind of thing that's,
and I do think you need a person to teach.
Yes, but like in person though, you know, because
no, maybe not in person. And then we get back to the technology helping other jobs. Yes. That will happen a lot, but that doesn't mean replacing them.
Because the problem, I think the problem with let's say with competition is that there will be one teacher teaching the same thing that is better than others, and you don't need to teach that thing many times. You just need to record it and distribute it, and that's it, you know, like as at least.
So yes, and I really believe in online teaching, and it gets back to what we were talking before. Anyone can learn anything on the internet because there are amazing teachers on the internet that have already recorded it, right? Yeah. So yes, maybe on the one hand, yes, and there's the part of it that you really don't need the same thing explained 20,000 times. On the other hand, there is a difference, and I think this is one thing that we surely learned in 2020, is there is a difference between learning online and learning offline. So I don't think that schools are disappearing anytime soon, because I do think that the offline aspect of it is important. And then when you take it to the offline world, then you do need, I mean, there's a limited amount of students that a single teacher can handle. And then you do need many of them explaining the same thing, right? And so I think there's like both sides to it.
I think it's gonna change. It's not gonna stay like.
I think the incompetent people are definitely going to get replaced, and because if you're an incompetent teacher, then probably someone in the internet has done better than you, and then it's more accessible, right? It's as accessible as, and probably with better results, and then it's people are going to go to the online resource rather than coming to you.
Yeah, and plus there comes some other player and just do the translation. So you don't need a person from your, from your surroundings to teach you.
It's a very complex topic.
Yeah, that's what I'm saying. It's just not as easy as it looks. And but the thing is, I
think also translations and languages is the reason why that won't happen so fast, because I think for the guy growing up in the middle of Brazil, it makes a huge difference if the content is in Portuguese or in English. It's a huge difference. And in the internet, it will usually be in English and not in Portuguese.
You know why I'm bringing this topic? Because I remember back in 2018 or 17 or so, I don't remember exactly when, maybe more, maybe less, but when the last Mexican president was in charge or as president, he tried to change the education system I don't know if it was good or bad because I was not in the country. I was just watching the news and I don't have an opinion of it. But what I did see was that teachers were complaining that they were about to losing their jobs because they were supposed to be tested and they didn't want to be tested. So it's like, why are you testing me? Because if I don't pass the exam, I will lose my job. So fuck you, government. So everybody got together and pushed that back just so teachers could have a living. And that was so frustrating to see. And I was like, dude, like, and I cannot believe that people, well, okay, I can, but it's just, you know, like frustrating because they want to help them, but people don't want to be helped in a lot of times.
Goes back to what I was saying, right? If the road was a fair place, teachers would get paid as much as doctors. Well, doctors do go through a lot of certification and a lot of examinations before they doctor, as do lawyers, as do many other people. Well, probably those two.
But I think really top professors earn more, you know, because they went through a lot of things.
Well, yes, but professors are a bit different than teachers.
Yes.
Professors are a bit different than teachers. And professors usually have like side projects as well. They're not only teaching, they're also doing a lot of other side stuff on the side.
Exactly. And then just if you take all teachers, not everybody will earn the same. That's because of the same reason. That's the only thing. So it's complicated. So we came to a rabbit hole really quick, but yeah, definitely really interesting. So let's just change a little bit the gears to go really, really back to your master's degree. And because you were in, that was from 2014 to 2017. And in the meantime, you participated, first you founded the WARR Hyperloop team, and then you participated in the competition in LA in 2017. I also checked what was the meaning of WARR, or I don't know how you use it.
Wissenschaftliches Arbeitsgemeinschaft für Raumfahrt und Raketentechnik.
Exactly.
What's the problem with that abbreviation?
Easy. So
it's just a German abbreviation for the academic student group for rocketry and space flights.
Yeah, and it was,
translated it. There's probably an official translation, but it's just, sorry, Vad. Still love you guys.
No problem. But I also saw that it was founded in the 50s or 60s, or it was crazy that having.
That is awesome. They're a student group and they're actually really, really cool. They've been sending rockets for a while.
Yeah. So the question is, why did you start? Like, first of all, like, why did you want to participate? Why do you want to participate in that? And you know, because one thing is computers and computer science and logic and mathematics, and another
the other thing is the mechanical engineering part of it.
Yeah, exactly. So implementation, implementation, and then you come into transportation. So I think now we're coming more to the present.
So
what happened?
The whole mobility thing, right? I had always loved transportation. Basically grew up in São Paulo. Anyone who's grown up in São Paulo hates traffic because they have it just jumped. Because they have lost too many hours of their life in traffic. So yeah, São Paulo traffic, definitely a huge problem. So I had actually already been working in transportation even before the Hyperloop. So during my bachelor, for example, I did my bachelor thesis in Singapore at a traffic simulation research group. It was a research group that was developing a traffic simulation, and I helped with the development of a few of the components. So my whole thing with transportation and mobility is actually already before the Hyperloop. And the whole story of the Hyperloop, right? The Hyperloop concept is an amazing concept. I was towards the end of my master's, at that point where you should be searching for a thesis and should be thinking about how to finish it. And as any good student, instead of searching for a thesis, I was on Facebook. Just dumb scrolling through Facebook, literally dumb scrolling through Facebook, when I see this post from Wait But Why, which is an amazing page that I can only recommend, from Tim Urban. Wait But Why. It's a blog. It's a blog that explains very complex scientific topics in a very easy stick man figure anyone can understand language. It's really awesome. And I already knew them from before, and therefore I had followed them on Facebook. And therefore I got this post on my Facebook newsfeed that Wait But Why was talking about the Hyperloop, because he was doing a series or starting a series on Elon Musk. And therefore, he was one of the first people who get notified when the competition was announced, and he wrote a post about it. Even it was for Tim Urban on Wait But Why usually writes like humongous posts, and this one is actually quite short, and you could read it in like 15 minutes. Awesome. It wasn't the first time that I heard about the Hyperloop, because I had heard about it in 2013 when Elon published the alpha study. But it was the first time that I looked into it in detail. And the whole thing was SpaceX is announcing a student competition for university students to build a prototype, to design and build a prototype. And for someone who was searching for a master thesis, I was like, that's a cool master thesis. So this is really the story of how me, dumb scrolling through Facebook, found, interesting master thesis.
No, because you have the potential of everything, you know, because it's like the project is there, you need to do your work.
Like,
so
why not?
Together.
I called a friend, my friend's from Armenia. I called her, and both of us got completely overhyped on the whole topic, and we're talking for hours, and then she went into, started researching and looking into stuff, and she's the type of person that when she digs into something, she digs deep. And I think the story goes that she, at some point, it became late and I went to sleep, right? I was like, awesome idea, we'll look to it. We'll see what we can do in the morning. But my friend, she's like, I'm just going to go in deep into it. I think she didn't sleep. And a few of her friends in Armenia also didn't sleep that night because they were researching into the Hyperloop.
But you were all together in the in tune.
Yes, I knew her from she was also doing a master's in computer science with me. She was a university friend. And yeah, so next morning, at some point I'd wake up and there's like many messages and comments from her about all these things, right? Ex-boyfriend from back then, and back then boyfriend, now ex-boyfriend for reasons, actually comes in and I tell him like, hey, Hyperloop, like this is a cool master thesis. And then he's like, we don't have time for that. And those are a few of the reasons why he's not an ex.
It was anyway. Time for you. Get out of my way.
It's a bit of a dangerous summary to the story, but whatever. Anyway, started looking into it, and I mean, I'm a computer science. I know enough about the world to know that designing and building a Hyperloop is not a computer science task. I was, I don't know, smart enough to realize that there's a huge mechanical engineering concept into it. And it's like, I have no idea about how to do the mechanical engineering part of it. So let's find the people who can. I literally opened the mechanical engineering website, the faculty website, and I was going through the chairs of the website. And I was searching for something like rail, train, faculty, chair, whatever. That TUM at that point did not have that faculty, or at least not in the mechanical engineering building. But I did end up finding the people of the aerodynamic chairs. Like aerodynamic seems from my very vague understanding, I mean, you can even make an argument that the Hyperloop is under very low pressure, almost vacuum, and therefore aerodynamics shouldn't be that relevant. You could even make that argument. But from my understanding of back then, I thought aerodynamics is the one that was closest.
They know.
Went there. Actually, first I wrote them an email and they ignored me for a while. And at some point, I just literally went over and knocked at their door. Talked to them, and in like 5 minutes, there were 5 PhD students around me, the small master students, talking about the concept. I was like, interesting. We could support it and all. And they actually told me that I should talk to their neighbors. And literally, the neighbor of the aerodynamics chair is VAR. VAR is actually at the space flight and rocketry. So back then it was a chair, now it's a faculty. And they told me to talk to VAR for 2 reasons. A, VAR would find the SpaceX part of it cool, because maybe VAR doesn't have much to do about Hyperloops, but they do have a lot to do with SpaceX, because they do build rockets. Maybe not SpaceX-sized rockets, but small rockets that do get launched. They did find interesting the SpaceX part of it. And even more important than that, VAR had experience in building stuff, in building the actual hardware and the actual practical side of building prototypes. That's exactly what they do. That's exactly what they did. And I did that, and I did go to VAR, and at VAR I found the first, so the first 7 people from the team was me and my friend, and 5 people that I basically stole from other projects at VAR.
But okay. So the person who began everything was your friend that we need to go into here, and you were
me and my friend was like, yeah, she didn't sleep, I slept. And
but that's cool. So in that case, so you gather a team without knowing it, and then what? Like you just applied, so like, okay, we have a team, now we want to do it, and then you just send
it was a very, very iterative process. It wasn't like first get a team, second apply. It was a very, very iterative process. So indeed, I'm quite sure I'm quite sure I even applied before getting a team. And we actually applied twice exactly because of that, because like there was this online form that you needed to fill out and register, and I wanted to see what was happening after this online form to see if like, is there 20 other steps to this thing that I don't know. And so I'm quite sure that I even registered for a fake team name under a dummy team under my name. And I'm not sure how I even called it. I don't remember. I remember doing it, but I don't remember what I called it. And this was still when we were still gathering the first people with VAD and talking to people, and I had sent out emails and was starting to get some answers, but didn't really know who was going to be in the team, how the team was going to be structured. There was this whole topic, who's the team lead, who's going to organize this, blah, blah, blah. And so there was a lot of conversations and things going on, and I just wanted to know how the page was going to be, so I registered first. And it ended up not being much after the initial page registration. It was just one single page registration. So we actually ended up registering twice even. Later we did register under the WARR Hyperloop name. And I remember that VAD wanted to call it WARR Hyperloop, and that's how I wanted to be team lead. I wanted to be team lead because I barely need these people, so I wanted to have some control over the thing. But I didn't really care about the name, and since they had all of these other projects already, they decided on the name. That's how the name
that's cool.
Came up. They also did, one of the guys from VAR that ended up in our project actually designed the logo, which was also like VAR corporate design compliant, which was quite cool. To this day, I still very much like that logo.
That's cool. And the question is so everybody, I think a lot of people know about SpaceX or maybe also about Hyperloop. But what was the competition about? Like, and what did you do as a team there? Because you were not the only one there.
So very, very, very iterative process. The competition actually had several stages, and back then, today the competition is different. I think this year they don't even have a Hyperloop competition. They're not doing a boring company competition. Follow Toon Boring, they are awesome. Mm-hmm. I can highly recommend Toon Boring. And yes, but even the competition itself was quite iterative and also had quite a few steps to it. So we first needed a very preliminary design, then we needed a detailed one, and after we passed the detailed one, we got permission to actually build it. So and
everything was done. So the whole team went to Los Angeles?
A different, very, very, very long story in different parts of it. So basically, this whole going to VAD starting thing was like July, August of 2015. Then we had first preliminary design, blah, blah, blah. The first phase of it was actually going to Austin, Texas, at the ATM University. I forgot the name of the university. Oops. Where we actually needed to present the first part of it. Actually needed to present the design and to even get approval to build. And this was one of the hard parts of it, because I don't remember the numbers anymore. I'd have to look up the numbers, but a few like 300, 500, I don't remember the numbers. Don't quote me on the numbers. No, that's wrong. I don't remember the numbers. Had submitted designs, but only 30 teams were allowed to build. So that was like the first bottleneck of being allowed to build. So I remember when we were in Texas and we were like, we're allowed to build. This was like the first moment. And on the one point, that was the first moment. The second of all, that was like, oh my God, fuck this shit moment. Because we had this humongous compressor on the front of the pod that we had designed, because when we're designing it, we can do whatever we want, right? We had this amazing 12-stage compressor that was huge. It's like, how exactly are we going to build that thing? Like, how do you build that huge compressor, right? So that was also a bit also when we passed it and we had to build it, it's like, fuck, how are we going to do that? And so many iterations later, we completely changed the compressor. We scaled it down so much, and we ended up not building it, but buying one. Also very big, very big advantage of it. But you know what? The compressor that we ended up buying wasn't as awesome as the one as we had designed, but it had the amazing advantage that it existed.
Yeah.
It was like, actually physically existed. You could actually touch it, you know?
The compressed time, yeah.
Yeah. So also getting it to work is better than getting it perfect, right? We absolutely scaled down the compressor so much, as with so many other components of the pod. Basically, the braking system, we had to start from scratch. We had to basically redesign the complete thing because we needed to redesign something that we would be able to build. So when we got back from Texas, the first task was like, okay, first task is A, redesigning the complete pod. B, for that we need more into something buildable. B, for that we need more people, so we need to find people. C, we need money because building this is going to be expensive, so we need to start looking for sponsors. And that's when things started scaling up a bit more. When we got the approval to build, that's when things really started to go crazy. But that's, yeah. And then by the end of it, so Texas was January 2016, where we got the approval to build it. And then all of 2016 is basically the year where I didn't have a life. 2016, I basically didn't exist. As did anyone else on the team, may I add. And then January 2017, we go to LA, and answering the question, did the entire team go to LA? We separated into, because it's quite expensive for 35 people to go to LA, but we really wanted to do it because everyone had worked so hard. So we ended up separating it into phases. There were the engineers who were really important to be there for the actual thing to work. And I think that was like 15 people, if I'm not mistaken, who went there 2 weeks in advance, and they were there for like 2 complete weeks working on it and blah, blah, blah. And then the rest of the team only went for the competition day for 2, 3, 5 days in total.
Oh, that's cool.
So we sort of separated so that at least everyone could be there on competition day, but that the people that we needed to work there before was there already before. And getting the money part of that to work was also a whole different topic.
No, the cool thing is you won. Like that's crazy, you know. And I mean, winning. Like, look.
Do you want the complete story on that?
But look, even if whatever, if wouldn't be Hyperloop, it would be another thing, like another kind of technology, and you win. That's crazy. Like, you were competing against other 30 teams at least, or 29. 30. I don't know how many people were involved. Money, sweat, work, and you won. And you know.
So definitely yes, and definitely there is the amazing part of it. But then again, there's also the luck part of it. Here's the actual story behind the win that I'm not sure if I've already told it like this. Okay. So indeed, we did not win the category we wanted to win. Here's something that most people don't know. In this first competition, there were actually 2 categories, design and fastest pod. And we always wanted to go for the design category. We built and optimized. Going back to the optimization, we optimized for the design category. That's why we had our huge compressor on the front. Our compressor made 0 sense on the speed criteria. It did make sense in the scalability and design criteria, but we still had our amazing compressor in the front. We optimized for the design category, not for the speed one.
But with design, you mean like how it looked and how it performed?
No, technical design.
Okay, but from okay.
Functionality,
okay.
Yeah, functionality and technical design. That's what we wanted to win. And then our main competitors, so basically we had like 2 main competitors, the Delft team and the MIT team. The Delft team, on the other hand, they had optimized for the speed category, and they ended up taking the design category. So we completely switched. We wanted the design and got speed, and Delft wanted speed and got design. And the reason for, and there's a very funny story as to why. MIT had some technical problems just a few days, like basically a week before. And if anyone of the MIT team is listening to this and I'm saying something wrong, I'm deeply sorry. I do not know the details of the MIT team, okay? But just a few days before the competition, we needed to go through this testing week, basically, and proving to SpaceX that all of the components were working. And there was this one day where like this huge rain fell down, and I think the MIT electronics got wet, and I think that started giving them technical problems. So it's not that MIT wasn't good, they were amazingly good. But yeah, they had technical problems. And I mean, at the end of the day, MIT electronics got wet and ours didn't. Is that because we're better than them? Of course not. That's because we were lucky. So there's always like the luck part of it. Obviously it's awesome to win, right? But they're very, very, very much. Why did we win the fastest pod? Basically because Delft had huge magnets on their pod. We also had huge magnets, but our system was modular, so we were able to remove our huge magnets. We literally removed our huge magnets 5 minutes before the competition, okay? 5 minutes before the run. Delft couldn't remove their magnets before the run. And it so happened that SpaceX was allowed, so that our pod did not have any propulsion. The propulsion was supposed to come from a pusher from SpaceX. And SpaceX had been promising us that this pusher was going to send us to 300 kilometers per hour speed. So we had all designed for this, both us, Delft, MIT, all the teams were designing to this, okay? And they even had this table, if this is the weight, this is the speed. If this is the weight, this is the speed. And we were designing according to that because that was the specification that we had. That pusher from SpaceX had major technical problems and simply did not reach the speed that they told us that it would. It reached 94 kilometers per hour, and everyone, the three teams competing only made the 94 kilometers per hour because the speed was determined by the pusher, not by the capsules. None of the teams had propulsion systems. The reason why we won fastest pod is that Delft and its magnets, basically the magnets were there for levitation, and we also wanted magnets for levitation, right? And the levitation curve is basically the magnets for levitation. Basically at low speeds, the magnets are a huge drag. They are almost like a huge brake force, but at high speed, they will levitate. And so we all wanted to reach the high speed and levitate. Yes, we did. But because of the pressure problems, we knew we were not going to reach the speed that we wanted to. So we knew we were going to be below that threshold. So, and we knew that at the lower speeds, the magnets were more braking us, more making us slow than anything else, which is why we removed our magnets 5 minutes before the competition. That's when we got the news from the pusher status, right? We moved the magnets because of the Delft design. They couldn't do the same thing. And since they had the magnets in the pod, basically as soon as the pusher stopped pushing, their pod stopped, like, I think their pod only rode a very few meters after the pusher and stopped in the middle of the tube. We won fastest pod because we removed the magnets, and therefore we were the only team that made it to the end of the tube. It's not because we were fast, it's because we were the only ones that made it to the end.
But, you know, like, luck has also a big component of preparation because, you know, like...
Also, it's a big component of luck.
Yeah, but I mean, there was preparation on it.
Yes,
like,
yes,
you didn't plan for it, but
yes,
but there was also all the work of the team. Somebody thought about it.
Obviously, no. Obviously, making the whole thing modular was a huge advantage that we had. The fact that we could remove it 5 minutes was a huge advantage, which was because of our modular design. Yeah, definitely yes on that part. And Delft didn't have this modular design, and therefore they couldn't remove it 5 minutes before. And definitely the modular design has a lot to do with preparation. It also has a lot to do with everything that we were talking about earlier for getting it to work, right? The modular design, we did it because it would allow us to easily add and remove things and iterate on 100 and 1,000 times, because we really iterated on this thing many, many times. And the modular design was completely necessary for those iterations to work. So, and those iterations is absolutely what we were talking about earlier, for first get something to work and then make it better, right? And that's exactly what we were doing. And yeah.
Yeah, but there is a saying, a win is a win. So, so yeah, no, I mean, that's really cool. And you know, like it was a fair game because everybody had the same circumstances. Nobody planned about it. Nobody, like everybody had the same bad luck or bad components. So yeah, so that's cool. That, I mean, you won.
Yes, no, don't get me wrong. I was screaming my head out that day.
There's
videos of me online screaming like a crazy person.
Exactly. And when you won, what happened? Like, of course you were happy and all this stuff, but what happened?
So for me, there were two moments when I thought we actually have a chance of winning this. The first one is when we passed the last test that we needed to pass, when we passed the open tube test, where it's like, and everything worked and the compressor was on and the compressor turned on and it was working, and even the brakes, when the brakes engage, is like,
yeah, everything is working.
It's actually working. So that moment for me was the first time, like, and this happened at night, so like 11 in the evening, 11 at night, one of the days of the testing week. For me, that was the first moment where I realized how we have a chance for that. And the second one was Delft had their run before us. And when Delft's pod stopped in the middle of the tube, I had like, their pod stopped and ours won't. It means we are getting to the end of this. It means we actually, like, it means we're down to 2 when their pod stopped, which means we're down to 1, which means, oh my God.
We have a chance of winning this.
And I absolutely started freaking out at this moment, and I go to one of the engineers in the team and I was like, Maxi, we're like, their pod stopped, like, completely going crazy. And Maxi looks at me in like the most serious engineering technical face in the world. Of course their pod stops. Their magnets, they had magnets, and then the magnets acted out as brakes and they made their pod stop. I was like, you're not reading the consequences of this, are you? Like, you're giving me this technical answer and I agree and you're right about this, but dude. And yeah, Maxi got a bit annoyed at me. And then a few hours later, we had our run and it did work out. And obviously it was awesome. And then it continues, right? Then after we had our run, we were the last team to run. Were we the last team to run? I don't remember when MIT ran. And then you need to pack and start preparing to come back. And then after that, it's packing, unloading the pod, making sure that everything is there, looking at the data, looking at the sensors, then there's like the whole engineering part of it, right? First look at the data. Did everything really go as planned? And
all this information, just curious, all this information and the results were...
were they published?
No, wait. Were property of SpaceX or this company? Or it was like...
It was property of us. SpaceX had a non-exclusive usage rights. That was the contract, the legal wording of it. They had non-exclusive rights to it, but it belonged to us.
Oh yeah, because then it's like, oh, just take this and take it to...
No, it belonged to us. They had non-exclusive rights to it.
Oh, that's cool. No, yeah, that would be, I don't know if terrible.
And yeah, then we started packing, and I remember that like 3 hours later I was sick. When your body just gives up. Obviously the team went partying that night. I could not go partying because I was just dead sick. Like 3 hours after the competition, I was like, I'm out. I did not go to the party. I missed the party. Sorry.
No, I mean, I think every time like you just let go all stress or whatever you were carrying, it's just like your body's just like, okay, now breaks. No, but that's good. Congratulations. I mean, it's still...
I can talk hours about the Hyperloop.
Even the story is just inspiring. It's just like the participating, the creation, the problems. It's just really, really, really cool. And after you participated on this, you went back to... Oh, by the way, wait. Before going back to your PhD and why you are currently doing, that's what the next question is going to be. I wanted to ask you, what do you think about technology or the differences in technology or development from the different teams? because you were representing Germany and the TUM, so Technical University of Munich. But there were all other teams, local, so from America and other countries, I guess. So what do you think about the difference in technology and developing and IP and?
I think that's one of the very cool things about the format of the competition is that it allowed many different technologies and concepts to get tested. Mm-hmm. So for example, we were one of the only ones to have a compressor, but then there was Lehigh. So there were only two teams who had a compressor, us and Lehigh.
They were from, I guess,
US.
Huh? US?
US, yeah. Lehigh had this, Lehigh had a compressor that made ours look small. Lehigh had a compressor the size of the one that we had designed and given up on building. I don't know how they got it, but it was so just awesome to see it. Just like they had this humongous thing. And they were using the compressor for a different means than we were. We were using it for drag reduction, for basically removing the air from the beginning of the tube so that air doesn't accumulate / choke in the beginning. Mm-hmm. And we were basically sucking the air and passing it through the pod and expelling it through the back. Lehigh was not only doing that, so they were sucking the air as well, but instead of passing it to the back, they were using it for air bearings, and they wanted to levitate not through the magnets that we had, but through air bearings. And this is actually how the Hyperloop is described in the original alpha study from Elon Musk from 2013. Is he uses the compressor for air bearings and uses air bearings for levitation, and Lehigh wanted to implement exactly that. Unfortunately, I'm not sure what their problem was, but unfortunately they didn't get to test it. But I do think it's like, at least not in the final round in the tube. They did go through quite a few tests. I'm quite sure their air bearings worked. And I think that's one of the cool things about the competition format is that it allowed so different concepts. Like there were people who had active magnets. We had our passive magnets, right? There are people who were using the magnets not only from levitation, but also for braking. And therefore we're actuating them in different directions. And there were just so many different concepts that it's really one of the cool things from the competition.
But I think that made you nervous and at the same time excited, right?
Like, yes, because you wanted to see how the other.
We didn't think about that. Looks good.
It wasn't a competition. Obviously it was a competition because we were one against the other, but you also generally wanted to know just from an engineering perspective, how is this concept going to operate under these conditions? Mm-hmm. We're also like curious for the results of the other teams, not only for yourself. And that's really, really cool.
Yeah. I think we talked that about last time we met each other. It's like being in an environment when you can talk to other intelligent people.
Yes.
That's super amazing.
And there were only intelligent people in there. Only intelligent people, really. A few of the smartest people I have ever met in my life, I met that week on the competition. Probably most of them and most intelligent people I met in my life were in that week.
But I mean, you were also participating in this group, so in this environment, and that makes you also that intelligent. So that's good. Yeah, there is a saying. I don't know if it's only in Spanish, but it's like. The saying is like, do you prefer to be like the head of a mouse or the tail of a lion? So
how do you say it in Spanish?
Cabeza de ratón o cola de león.
Yeah.
So it doesn't matter, you're part of it.
Yeah.
I don't have enough information to say you were that little or that much, but you were part of it. So I think that's the cool thing about it. And
it was definitely an amazing experience that I would definitely never regret.
Yeah, amazing. And the question.
Don't get me wrong. The Hyperloop did cost me a job at Intel and a relationship that at the time, at least, I really, really liked. And I could tell a long story about how the Hyperloop had a very big effect on that relationship. And don't get me wrong, the Hyperloop had so many problems. I could go on for hours on this. A few of them that I am not sure if it was worth it. And a few of them, and there were so many times where there were infinite amount of times where I wanted to give up. There were a few times where I actually did give up. There were times where I did give up, and the only reason why I still went to LA is because the team was still pushing it. So my relationship ended in the middle of the whole thing, right? And there was this day where I was destroyed because my relationship has ended, and it was just really, really sad. And I didn't do anything work-wise for like 2 weeks because it was really not well. And it wasn't because I was doing something in the meantime. I wasn't doing nothing in the meantime. You can easily see my calendar, all things canceled, all things deleted. You can easily see my calendar when it happened. But the team was still there, and the team was still pushing forward and still working their ass off and working like crazy. And this is the feeling that I really, really missed from those days of even when you're not doing anything, things are still happening, they're still moving forward because of the amazing people involved. And then there were other times where other people were sad and didn't do things that I did. And somehow the teamwork still pushes the whole project forward, that you still do something, right? And even the times that I did almost give up, the people didn't allow me to give up. It's like, Mariana, where's the thing that you said you were going to do, you know? And at some point it does go forward and it does add up to something.
I think for this, there is a saying, I love it, and it applies for this, and you can remember it. You didn't come this far to just come this far.
Yeah. And for me, that's a lot about one step at a time. One step at a time is really my life motto, because one email at a time, one test at a time. When our compressor exploded, we were so proud about our compressor, it exploded. It literally exploded. Like, what do you do when the component that you're most proud of in your whole design explodes? What to do? And yeah,
Cool. And just to close this part of the conversation, like, how do you, like, after that part of your life, what happened with that technology? Like, because you are more into mobility and sustainability. Yes. So what happened so far, and what do you see regarding that technology or similar technologies for mobility, at least in?
So the reason why I eventually left the Hyperloop is a bit of what you're talking about. The technology of the Hyperloop works. We've proved that much. It will work, and I 100% believe that someday in the future I will ride a Hyperloop. I really believe that. And you know what? It's not that far away. Virgin Hyperloop 1 had their first people test a few months ago, months. Time is abstract.
2020.
2020, this year. Right? And so the technology of it definitely works and definitely is very interesting and an amazing project. The reason that I eventually left is that the problems on the Hyperloop today are not technical. They are very much business and political, and regulatory being a very big part of them. Like, what are the regulations that you need to even be allowed to test something like that? And in 2020 and now, those answers are starting to come up. So people are starting to talk about regulations for this, which is really, really awesome. But that is simply something that takes a lot of time, because regulations take long and nothing will ever get out of the ground if it's not profitable. So there's also the whole business side of it that we still don't have data how any Hyperloop business model is going to look like and if it will ever make money, right? So the cost is absolutely one of the problems involved. And the fact that the problems were not technical, we're like, okay, so what do I do? And then what I also realized is if we want to solve transportation, if we want to solve mobility, there is so much that we can already do today with the regulations and frameworks that we have, technology that we have today, that would have as high an impact as the Hyperloop. And it's practicable today inside of cities, which is why I started my PhD in the direction of integrating different modes of transportation. And the way that PhDs work between what you start and what you deliver, there's like this huge gap. So that's what I wanted to do when I started my PhD, was integrating different modes of transportation. That is not what I ended up doing in my PhD, but it is to some extent what I want to do in my startup.
But that's, well, it's my only wording here, but that's crazy because that experience took you to the, okay, now I need to do my PhD and want to pursue this. That's cool, you know, like.
Oh, you make it sound much more decision-led than it was. You make it sound much more rational than it was. It was not that rational. It was like, okay, I finished the Hyperloop, awesome. I know I don't want to continue this because what should we do in the next round? So what to do? And then I had several different options back then that were open, and for different reasons, each of them started not working out. And then PhD was like sort of the one that was left. And it's like, it's definitely not a bad option. No one will ever say that it's bad to do a PhD. There were no arguments against the PhD. And for me, like the big argument for doing a PhD was it would give me the time to decide what I actually wanted to do, because I didn't know what I wanted to do because I was lost. So the PhD would give me the time and the flexibility to decide that. And B, my professor I knew from day one that my professor was going to retire. So from day one, I knew I had my deadline, which meant that I have a clock ticking, which means I couldn't get lost doing other things. And probably if it wasn't for that, I would never have done a PhD.
Well, you did it. So just to
Our doctorate, by the way, I didn't do a PhD, I did a doctorate. So there's a difference. It depends where you do it. If you do it in Germany, you're doing a doctorate. If you do it in the US, you're doing a PhD. I did a doctorate.
Okay.
My professor would correct me if he heard me saying I did a PhD.
So you are now, your title, official title, what is?
Doctor. It's Dr. Mariana, it's not PhD.
Doctor.
Yeah.
Frau
Doctor. Yeah.
Oh. No, it's super good, super good. I mean, titles here, at least in Germany, are really, really well welcome.
If that's good or bad, but whatever.
Yeah, I mean, it's part of the society. I always laugh when somebody is like, "Oh, call me Herr Doctor, Professor, Engineer." This is like, okay, too fun. And during your PhD, you already mentioned why do you study it and in which direction you wanted to take it. What is this decision, or why did you chose to start Moowe? Sorry, yeah.
So yeah, I was very passionate about integrating different modes of transportation, because I do think that any type of solution that you find for, like, go back to the traffic problem, right? The São Paulo traffic problem. I think that any type of solution that actually has a chance of solving São Paulo's traffic problem will not involve a single mode of transportation. I really think it will involve a combination of different, because there are so many different types of people going from A to B that have completely different need, and therefore so many different modes of transportation are needed and exist, right? Both. How many modes of transportation exist? Which is why I still to this day, I believe a lot in integrating many modes of transportation, what we call multimodal routing. So for me, multimodal is when you use two different modes of transportation in the same ride. So something like changing from a subway to a bus is multimodal. Something like taking the car to the end destination is not multimodal. Other examples of multimodal rides are something like taking your bike to the subway station and continuing there with the subway, right? That's also multimodal route. Or park and ride, taking your car to the subway station, parking your car there and continue, also multimodal.
So that's the definition, sorry for my ignorance. So that's a definition of smart mobility, so optimized.
That's the definition of multimodal transportation.
Okay, okay. And so,
yeah.
Yeah, okay. So like, in your opinion, the best way to solve that or to tackle that kind of issue, not only here in Germany, but also in other countries, is to use what we already have and optimize on that or work on that.
And integrate that better to other things we already have. So for me, the way to solve transportation definitely is through multimodal transportation, definitely, yes. I really think that the only way to solve is integrating the different modes of transportation, one with each other, much better. And some cities in the world are starting to do that. I mean, many people have park and ride solutions worldwide. Very few applications worldwide can actually calculate the multimodal route from such like getting the bike to the subway and continuing. Google Maps can to this day not do that for Munich, though they are starting to in some cities. In Munich, they still don't, basically because of data availability. And yeah, those are things that we started working on that Moowe actually does. So Moowe actually can calculate the route to take the bike into the subway station and continue there with the U-Bahn. And
okay. So when you mention integrate, that was the keyword there. So integrate, you mean involving technology
no, involving more than one mode of transportation.
Okay, and how do you use the technology to integrate this different?
Then we start talking about graph theory. Beautiful, beautiful, beautiful field of computer science. Probably the most beautiful field of computer science. The math of graph theory is it's just beautiful. You can do a very nice graph theory optimization on how to calculate the multimodal route. But yeah, how to use the technology and graph theory is also a point, right? If graph theory is really one of these areas where if you want to find the optimal solution, it can get very complex. But what we can do is find an okay solution. Is find a good enough one that works, and even if it is not the most optimal one in the world. And what Moowe started doing as well was adding several constraints to the whole thing, to the route. So we actually personalize the route much more than Google Maps does. We can actually calculate a route where you are allowed to configure, give me a route where I will bike at least or at most 5 kilometers. And then the at most part is easy enough to implement, because if you're over it, you just drop the route and look into a different one. But at a graph theory level, the at least one is a very interesting problem to solve, which actually was solved through a student that I supervised during my PhD, a very smart guy.
Wow. So I'm just trying to follow up what you were saying. And it's like, I don't have enough information to say this or that is correct or so. You correct me for that. But I understand that not all transportation is managed from the same company. So for example, right now we have so many apps for mobility here. So what you're saying, at least that's my understanding, is like, how do you connect all that possibilities to give you the best or the current best form or way of transport yourself? Is that correct? Or it's like giving you options of, okay, you need to use this service,
so
or
basically what Moowe does is that it gets the whole route calculation process that many other people do, and we add 2 layers to it. A, the personalization, all the constraints that I talked about, and the integrating different modes of transportation that I talked about. And B, and the thing of it is, when you do that, the first thing, an interesting thing that happens is that the number of route possibility really gets really big, because if you're using more than one mode of transportation, then you have so many routes to choose from. So what we do in Moowe is that we sort these routes by sustainability. And then we bring in the whole sustainability aspect to it. Because solving traffic isn't just about reducing the time stuck in traffic. It is also about doing something for the environment. And the sustainability aspect for me is very important. So one thing I can promise you is Moowe does definitely calculate several different routes. The last one that we will ever show to the user is the car route. We actually sort the routes through which route emits less CO2.
But okay, so now at least the picture that I have is way better than I would ever imagine, in my opinion, because there are so many companies working towards this same outcome, even though they don't know it, maybe. Because, you know, like there are companies that they are trying to make their own way of transportation or make parking easier or whatever, but everybody working together and then linking them somehow, that's actually pretty good, like for you know, like not only for Munich, but
for the road.
Yeah.
Connecting the different modes of transportation is definitely something that has a huge potential of solving a decent part of our transportation problem. Basically, if you want to optimize traffic, there are 2 variables that you need to optimize for optimization. The amount of CO2 emitted, so pollution is definitely a big one. And one that most people don't imagine the importance is the number of people transported per square meter. Wow. The square meter part of it is so important. You know who are the bad guys of traffic?
But
The bad guys, the people who are responsible for causing traffic in the first place, are the people who are sitting alone in their car. If you have two people already in the car, then you're already twice as good as you're already using twice as less space than the person sitting alone in the car. And
that means you are mapping everything in units. So this unit is square meter. Okay, okay, that's great.
Pollution, CO2, and square meter. Those are the two variables to optimize for. Which means that things such as car sharing has a huge concept. I do define car sharing, let's call it ride sharing. Let's call it ride sharing rather than car sharing. Ride sharing. Things such as ride sharing have a very big potential because in ride sharing, you have more than one person sitting in the same car. Also, FYI, in case before somebody comes to me with a taxi argument, taxi does not count as two people because the driver is only there to drive you from A to B. It's the number of passengers, not the number of people, it's the number of passengers. If you are driving yourself and someone else, then those are two passengers, and that's okay. If you're just driving your friend to the station, then you're not a passenger, you're a driver, so that's only one person per car. It's the number of passengers per square meter. That's one of the most important variables to optimize for.
That's interesting. I mean, now that you're explaining it, now it makes sense, you know? That's one of the things.
And people do not understand, people cannot begin to realize how bad it is to sit alone in their car for the entire city and the entire traffic. They think, what difference will my car make? It's just one car, it doesn't really matter. It makes a huge difference, and you can prove that mathematically. If anyone is interested, I can gladly show the math behind it.
And just to complement that, what do you think about these electric autos? Or because I heard somewhere, or I saw somewhere, that it looks good and it's functional maybe right now. I don't know if it's business-wise viable or not I don't know, in the present or in the future, but it's like, oh, I have a business that does not contaminate. The problem is that to do all the rest or the previous work to that, there was a lot of contamination somehow. So what do you think about like e-autos and the implications about it, like present and future?
It goes back to the two variables I was talking about, right? CO2 and square meters. So if you're talking one person per car, then electric cars don't make any difference whatsoever compared to normal cars. Really? They are just as badass because they need the same space as a normal car, right? So if you look in the question square meters, they don't win a single point as far as I'm concerned.
But even though they use different source of energy, so that doesn't make
one step at a time. We're not in the energy part yet. We're in the square meters part. On the square meters part, they don't gain any points. On the energy part, on the CO2 emissions part, there is an interesting analysis to make. And my opinion of the end result of that analysis is it depends on where. So basically you need to factor in the complete life cycle, not just the emissions per kilometer. Obviously the emissions per kilometer tends to be much smaller for electric cars than for internal combustion engines. So there they do get points, but depending on where, the emissions that go into the energy generation that they need are as high as, will emit as much as the fuel that are being output by combustion engine cars. In some places, it really depends on where, what is the energy that is fueling the electric cars. That's the first part. The second part is the production of these cars, which is then again, it's so definitely it depends on where, and it's definitely a place where regulations could have a huge impact. If in the production of it you're emitting as much CO2 as in other places, then you're also not getting a lot of CO2 points. And a big part of the component of electric vehicles is definitely the battery, and batteries are usually lithium-ion batteries, and lithium production is something that in some parts of the world is has questionable development impacts, let's call it like that. But that really depends on the where. I must say that all the arguments that are being made against the electric cars, all of them can also be made against internal combustion engines. So how the production is made also really depends on where and which car and which manufacturer for internal combustion engines. And basically at the end of the day is a question, how deep does the rabbit hole go?
Yes.
How much do you want to measure it? In average, if you average and you don't optimize for the last centimeter and you go for a pragmatic average, in average, at least in Europe, they are more sustainable than ICs. That's not an opinion, that's a fact, because the European energy mix is increasing the renewable percentage of it, and because Europe has strong production regulations. So in average in Europe, yes, that is, they are more sustainable. That is definitely not true for everywhere in the world.
The electric cars.
Yes.
Okay. Wow, that's interesting.
It brings us a lot to the Sustainable Development Goals. You know what the Sustainable Development Goals are?
Nope.
There are 17 goals that the United Nations came up with in 2015. And they are the 17 goals that if humanity were to focus in only those 17 goals, and the UN wanted to solve those 17 things by 2030, then we would have basically solved humanity and solved all of the world's problems. It's a list of the 17 things the world should really focus on. And in my opinion, anyone who is not working with one of the 17 SDGs can do something better for society. So the SDGs are Sustainable Development Goals. They do include things as zero hunger. And of course, it's really hard to achieve zero hunger, but you know what? One step at a time. You need to start somewhere, one step. They include things such as climate action, water beneath the ocean, gender equality, not only gender equality, but equality in general, because diversity is more than gender diversity, and the UN does know that. Access to education. I work a lot with my whole mobility work is a lot SDG 11, Sustainable Cities and Communities. And I can really recommend look up the 17 SDGs. SDG 17 is partnership for the goal. So basically connecting people who are working in all of them are very much interlinked with each other, right? So 17 is about connecting all the people working on each of them. And yeah, and if you just look at the SDGs, there's a beauty behind the simplicity of it. It seems so simple. 17 problems, that's all we need to solve. If you solve, there's health, there's education, there's poverty, there's climate action, 17 problems. That's all we need to solve to basically fix the world. And of course, each of the problems is as big as zero hunger.
Yes.
And of course, none of the problems are easy to tackle individually. But if you go one step at a time and do like even the tiny step of not sitting alone in your car, if you're not sitting alone in your car, you're already doing something for SDG 11.
I'm really grateful to hear this, to be honest, because I was not aware of it, but it definitely makes a difference if you know this before doing anything, because yes. it's just like, that's one of the main problems I have identified in my life so far. Something that you didn't know it exists, but it's so important that you know it exists. So I think the fact that you are sharing it, at least I want to check it. I will check it because it's a huge program.
It's from the United Nations, and there are people tackling this all over the world. And honestly, please, everyone, stop doing whatever you are and get yourself a job that does something for one of the 17 SDGs. You have 17 to choose from. Any of them will really make a big difference to the world.
That's a good direction.
I go for SDG 11 because sustainable cities and communities. And that's where sustainable mobility comes in. And I have a thing for sustainable mobility.
Oh my God. No, that's cool. Because now, like, my brain started thinking a lot of things, and it makes sense because I have interacted with people, like they are doing businesses or creating businesses or participating or looking for a job and interacting with all these people, not only here in Germany, but also, for example, in Mexico or Latin America. And to see that there is a path of progress, human progress, that's the beauty of it. It's just like, oh my God, there is a path. You don't need to invent it. You don't need to create something out of the blue. It's just like, there it is. You will help and you will contribute. And I think at least our generation is looking for contribution for getting some meaning out of our life in general, I would say. Not everybody, but so if you want something like that, then I think there is enough to do about it.
There really is. And none of the problems are small. They're all huge in size. but they are very concrete, and there are very concrete ways how to measure them and do something for them. And even small things like not sitting alone in your car and recycling your trash and eating less meat can have a huge impact.
But I think the first, if you ask me, that you didn't, but if you ask me, if you ask me, then you first need information to make a decision.
Yes.
You need to be aware of it, because I think, at least from my own perspective, by being here in Germany, I see so many things that I was not able to see when I was in Mexico, just because of the fact that I was living there. Just coming out, it's like, oh shit, like, there are so many things you need to do. You start comparing, you start talking to other people, you start looking from the outside. It's like, oh my God. And I thought we were doing good, you know, like something like this, or we were not that bad, or maybe some things were not that bad. They're actually good. So yeah, like just awareness in this case. Amazing.
Yes. Everyone, please research the SDGs, do something for them. That's my call of action. My call of action to end this. Let's change the world.
I will do some research and we'll share about it, because I also want to help about this. I think it's really good. And just before asking you the questions of that the audience made for you, just a quick soundbite answer, please, about how do you think about human future in space? Like, do you think we're going out and colonize, just in your own opinion, or we have enough problems here to solve, so don't worry about that?
Both. Both. Let's put it like this. Humans in space is not one of the 17 SDGs. It is a very cool topic. It definitely is very interesting. And I'm definitely happy if someone gets it to work. Yeah.
Would you go to space if you have the chance? I mean,
hell yeah.
Yeah, and come
hell
back.
Yeah. If I was rich enough to buy myself one of these tickets of rich people to fire, hell yeah, I'm the first one on the list. I'm not rich enough, sorry. If someone wants to pay me the tickets, donations accepted.
Well, you're still young enough at least to just still. You need to just get some more money, work on these 7 problems, and then you will get some, and then you can eventually, with technology and business, you can.
Don't get me wrong, it's amazing. It's really amazing. It's definitely like amazingly interesting, and it's like the purest form of engineering.
I think it's like the excitement of the, you know, like it's new,
yes, it's challenging. It's excitement, and it's actually not true what I said. It's not true that they don't do anything about the SDGs, because they do something. One of the SDGs is about education, and the excitement of space travel definitely does a lot for the education SDGs. So it's actually not true that it doesn't do anything.
And research and development, because like we need more and better technologies to reach that point.
Getting people motivated about engineering is something that space travel definitely does, and it's something that definitely has a huge potential with many of the SDGs.
See, that was a good question. Now maybe you change a little bit your mind.
I did change a little bit my mind.
It's okay. It's okay. Then, if it's okay with you, we are gonna continue with a couple of questions. So, because we took enough time of this conversation, I'm pretty happy and glad that we did. And I want first to like thank you for taking the time and give us some of your knowledge and your wisdom from your expertise. No, you have your own. You have your own wisdom.
Okay.
Everybody has.
If that's what we're calling it.
Yeah. No, I think so. I think you can learn. It doesn't matter how preferred one person is. You can always learn something, as long as you are welcoming the new information. So
that is definitely.
That's why I'm naturally curious. That's why. And yeah, thank you very much. So if I have many more questions, or the audience, I will invite you back to come. You know. So let's go for the questions. Okay. So in total, well, we have this couple of questions. So first question is from Emmanuel. He's an industrial engineer, and this question comes from Facebook. Is how does the finance works for the Hyperloop projects? Because if you're a student, how do you get the finance to build that thing? Does it come from the government, private?
So if you asked about the student, I'm assuming the question is about the competition, not about the Hyperloop as a transportation mean.
Yeah, to build it, just for the competition.
For the competition. Sponsoring. Writing many companies and many people about sponsoring. Shout out to Airbus, who gave us our biggest check and was our biggest sponsor. Shout out to TNG, who was our first sponsor, who gave us money when we were literally 13 slides of PowerPoint. So sponsoring different people at different times in the project will give you different amounts of money depending on how they like you.
Okay, but is that the only thing? Like, do they like you, or is they also?
Oh, well, no, we mean you need to prove that you're good, and you need to prove that the technology works. And I mean, huge shout out for TNG for giving us money when we were just PowerPoints. A few slides of PowerPoint. By the time we got money from Airbus, which was much more money, we had already proved that it was after we came back from Texas, and we had already proved that our design was good and that it had been approved by SpaceX, and the engineering behind it was good enough. I mean, you do need to prove that you're good at what you're doing, but basically go out, talk to people, show them and prove to them that you're good, make them like you, be nice. Honestly, this gets underrated. Just be nice. Be nice and prove to them that you know what you're talking about, and sponsoring.
And you can get some good finance. Good. So the second question also comes from Emmanuel. He asks what kind of like a checklist or what kind of requirements does wait, because I'm translating, so that's why I'm kind of like. Okay, what are the requirements from a country or from a city in general? Because obviously regulations are different everywhere in the world, but what kind of the general regulations or requirements does a city needs to approve to somebody to start one of these projects to build it in the city or in the country?
What do you mean with one of these projects? Transportation projects?
Yeah, he's talking about the Hyperloop.
The Hyperloop, okay. Oh, what type of requirements the city needs to approve in order to build a Hyperloop? If you're asking about the construction of a full-scale Hyperloop as a mean of transportation, then definitely the first of them is money. Having enough money to build is definitely a hard one. If that is not a problem, and that usually is a problem, the rest of the things are things we can find solutions to. So for example, there's the discussion if you should do it overground or underground. And the answer to that question is it depends. There are cities where you can only do underground because simply finding an overground straight line. So one of the components being you need as straight as line as possible connecting origin and destination. And sometimes finding a straight line between two good origin and destinations can be really, really hard. Yeah. Just because you don't have the space because cities are so packed already, right? And in those cases, it does make a lot of sense to build it underground. If you are Dubai to Abu Dhabi, where you have a huge desert in between, then you can do it overground as well. Different costs in different places. In some places, it's very expensive to do underground. Some places, it's really expensive to do overground. So definitely one of the big ones, one of the big requirements is a high enough traffic or a high enough flow between two cities. So so cities with many people going back and forth with are usually the best ones. Cities that are, let's say, in the range between
LA and San Diego or something like this, like LA to San Diego or something like this.
LA to San Francisco is the original one that Elon Musk talked about. LA to San Francisco is the original one. In Germany, I always talked about Munich to Berlin because many people going back and forth. In Brazil, you could definitely talk São Paulo, Rio de Janeiro. Definitely yes. It would probably make less sense to build a Hyperloop between São Paulo and Ribeirão Preto, where my family is from. Shout outs to Ribeirão Preto. Because the travel there is a bit smaller. So having enough people going back and forth, because that makes a difference on the economic side and the money side. If you have many people, you have more money to pay off. Distance is also a big one. So there's also the distance range where it makes sense, would be something between 100, more than 100 kilometers and less than 1,000 kilometers, less than 800 kilometers, something like that. So for example, I don't think we will have a Hyperloop anytime soon between Munich and São Paulo, simply because flying is cheaper than building an evacuated tube across the Atlantic. but cities that basically these cities where, you know, these very stupid flights where you just go up, fly for 2 minutes and go down. Those are the flights that are very good for Hyperloop for Hyperloop flights. Places that have several flights per day with less than 3 hours flight are good Hyperloop.
Europe,
are good Hyperloop pairs.
So Europe could be connected. Like...
Europe could definitely be connected. Europe could definitely be connected, and there are companies working on it.
Oh my God, crazy. Okay, so the third and last question comes from Eduardo Matos. I think you know him from LinkedIn. He asked, could working from home improving sustainability and mobility in big centers as long-term policy?
As long-term policy, he knows exactly my opinion to this. So definitely there's difference between theory and practice, right? In theory, definitely yes. In theory, definitely yes. And my opinion about Corona is everyone who's talking about sustainability, the dream of sustainability is the behavioral change. Corona proved that the behavioral change is possible. It from one day to the next, everyone was working from home. So it means that the behavioral change is possible. Corona, for me, that's the biggest advantage of Corona, is the change that it is possible. No one can ever say that it's hard to change, to fight climate change. Corona destroyed that argument. Thank you very much. So in theory, definitely yes. In practice, I read something on the internet last week, sometime in 2020, saying before we start talking about how much we want to go back, let's decide how much of the old life is worth going back to. And I think that's really the case. I don't think we should go back to everything that we were doing. I think that is horrible for the environment, and those are really things that desperately need a change. And so let's try to be optimistic, and maybe we can keep home officing more. And you definitely do not need to get into a flight for a 2-hour meeting. That can happen online.
Almost everything can happen online, right? Right now, like nowadays.
Corona said yes, right? In 2019, most people would have answered no to that question. In 2020, many answered yes.
That's really good. So with that, we can really close to the questions. And I want to thank you very much again for the time you took, and also the interest of participating. I think I'm really glad and grateful for it. And just one last question that I would like you personally to share with us. What would you tell to, that comes from me, what would you tell to either women or young women that wants to participate in one of these 17, solve to one of these 17 problems, or participate also into the STEM programs?
Get started, just do it. Honestly, just do it. On the technology side, we discussed a lot. There's everything you can learn online. You don't need more than an internet access and time. On the SDG side, there are a lot that you can do, even just by changing your personal life. It doesn't matter if you're a woman or man, everyone can do something for them. Everyone can do something for them. Everyone can recycle better than they do. And everyone thinks it doesn't make a difference. It makes a huge difference. Everyone can eat 1 less meat per week. Everyone can take 1 less ride per car, and maybe walk, and maybe take someone with you. Everyone can do something. Many of these changes are not big. Okay, just do it. Honestly, just do it. Stop making excuses and just do it. Okay, big changes start from small changes. Okay. Yes, 1 step at a time. 1 step at a time. 1 step. Start with 1 step, and you know what? Then you start recycling. Then you tell your friend that you start recycling and explain to her how it is. Then that's 2 people recycling. Then that's 1 next step. And then 1 step at a time. Let's finish with that. I love it. 1 step at a time. So thank you, everybody. Thanks for hearing this, and see you all, and have a good holidays. Thank you very much. Thank you for the invite. And happy holidays. Happy New Year for everyone.